Good morning, everybody, or good day, no matter where you are. I am Patricia Dugan. I am coming to you live from San Francisco, California, so it is 9 a.m. for me. And today we are having an online traffic meetup that's going to be very amazing, and I'm super excited. So let's start with a little intro. First, my name's Patricia Dugan. I'm on Twitter. Then we have Traefik on Twitter and hashtag Traefik. Today, we are going to talk to you about some really cool stuff, but let me tell you what a traffic meetup is so there is no confusion. Traffic online meetups answer interesting technical challenges that are solved by using traffic and/or mesh. And so they're 1-hour sessions and you come on board and they're demo rich and they're always presented by someone awesome. And so we hope they are worth your time. We intend for them to be. And then they go to the YouTube channel, of which I will share the link, and you can subscribe so that when it is uploaded, when the video is uploaded, you can watch it at your leisure. Did you know that you can become a traffic ambassador? A traffic ambassador is someone who does extra special stuff to help encourage the use of traffic and share your expertise around it. You can become a traffic ambassador by supporting code contributions, community contributions, and content contributions. So I will share a link in the chat box so that if you write a blog about traffic, or if you create a meetup about traffic, or if you contribute code to traffic, that you're rewarded and we will promote your work amongst the community. Another thing is we are excited because Containers just closed our Series A. Therefore, we are hiring. So if you're looking for work and you love to work with Go, Golang, and you like Kubernetes and the microservice ecosystem, then please go ahead and apply, and I'll share the careers link in the chat box. And then also we have a ton of online meetups coming up. So I will share our events links so you can see what suits you. And people are typing me, and I just need to make sure. Yes, this is live, everybody. So there's live. So I'll share the events with you. So if you want to come join us for more, you can. What do we have in store for you today? We have the most exciting online meetup. I love working with this person. It is Jakub Hajek from Warsaw, Poland. He's going to present container orchestration with Traefik 2.x. And he's with Cometari Solutions, and they use traffic on a daily basis managed by Docker Swarm. So that's what we're going to talk about. And now I've told you all of the things except no secrets, but maybe next time. So for now, we will hand this over to Jakub, and he's going to show us what he knows. Thank you for joining us today. And Jakub, take it away.
Hello, good morning, good evening, wherever you are based in. I hope you can hear me very well. So let me share my screen. I will share my entire desktop, and let me open my presentation. Hopefully you can see my screen. So let me start. Today I would like to talk about the container orchestration with Traefik 2.0 and 2.1 because there were two major releases recently, and I'm going to go through most of the crucial and key features which have been implemented by Containers team. So just briefly, let me introduce myself. My name is Jakub Hajek. I'm owner of Cometari, and I'm also a technical consultant working for my own company. And I started my professional career a few years ago. It was almost in the 90s. So when I was working for like a regular system administrator, I was managing infrastructure in the traditional way. There were no any automation tools. There were no any configuration management tools. So we did our work manually, but we tried to implement DevOps because we communicated together with our colleagues. We tried to spread the knowledge, share the experience. And this is exactly what I'm going to do right now when I was managing my own solution company. So we implement DevOps culture. So this is actually what Cometari is doing. And we provide consultancy in implementing DevOps tools like Docker Swarm, Kubernetes, and of course, Traefik. We provide workshops and of course, software services, because everywhere in all of our projects, somewhere on the bottom of our work is just a software development. So as I mentioned, our expertise is DevOps. We do a lot of projects around Elasticstack. We analyze a lot of logs using Elasticstack, including also Fluentd, and it's a very, very nice stack. And of course, everything what we are trying to do, we are doing in a cloud native approach. So all of our services are Docker based, and today I will talk more about it also. We are from the travel tech industry because my previous experience is travel tech. So our customers are from travel tech, but as I mentioned, we are not just integrating APIs, but we are trying to provide more values to the companies by implementing DevOps culture and all the tools which are related to DevOps. So, and this is just a motto I'm trying to use when I'm working with customers, with projects, that everything what we are doing like engineers, it should provide the value. So I know that we can implement some solutions, some tools which can generate problems, and this is not our goals. We should keep everything, we should try to keep everything simple and just provide values by implementing the tools we are using. For example, Traefik or any other tools, they should provide measurable values rather than generate new issues. So what is the goal of my presentation? So just today, I would like to show you how we use Traefik on our daily basis and how Traefik help us with the distributed systems. Because now we use containers in mostly everywhere. The containers are spread across our infrastructure using a different orchestration tools. So we are talking about the distributed environments, distributed systems. And Traefik is perfect fit to that understanding. So the presentation is about the containers orchestration. So I need to talk more about how I understand containers and exactly what are the immutable containers, because we need to need to use immutable containers, but to understand immutable containers, we should know what is mutable. So let's imagine that if you managing servers in traditional ways, you log into server, you implement any change. For example, you update configuration file or you install any package, it's incremental change. If you have one server, that's not a problem, but if you have multiple servers, it's prone for human errors and it's not repeatable. It's very difficult to roll back to the previous state, and it's just a mutable. It's incremental change. And if you have a few colleagues working on the same environments, it can generate real problems. So in referring to that, we have something which is called immutable infrastructure and of course immutable containers. So there are no any incremental changes to the container you develop. This is just the image which contains base image and the source code of your applications. Once you develop and connect these two pieces together, you have a image which can be easily deployed across your entire architecture, infrastructure, and can be scaled up horizontally. So that's my understanding of the immutable containers. And advantages of this solution, this approach, is that there are no any configuration drifting. So once you build the image, it's immutable. You cannot change the image. Of course, in case of some troubleshootings, you can log in directly to the container and do some changes, which is called imperative updates. But it's not, of course, recommended. Definitely, this is the anti-pattern. But it's nice to know that there is a solution that you can possibility to log in directly to the container and implement any change. Once you have immutable containers and you use tools such as Traefik, you can go and implement, let's say, canary and mirror deployments, which have been implemented in the recent versions. And it's easy also to roll back to the previous version, because once you develop your image, once you build your image, you can store it in the registry, in the Docker registry. So you have versions. You can have a previous version and the newest version, and you can easily switch between those versions just to rollback in case of any error occurs. So I hope it's clear. We can move forward. And so immutable containers currently they are at the core of any distributed system. So once you have a container and you understand that approach, you can move forward with orchestration tools, Swarm, Kubernetes, whatever you like it. Okay, so let's go. What exactly Traefik is? Traefik 2.2.x. What are the key features? So the major change it's that team implemented TCP support. So if you have any TCP-based applications, you can easily use it. In the previous version 1.7, for example, we were able only to use HTTP services. In the new versions, we have a new also convention name, which is router, service, and middlewares. So in the second row, I just try to compare if you are if you know the version, the previous version 1.7, so you can refer that the router, it's a front end, service, it's a backend, and middlewares, it's a rules which you can implement it to play with your requests. And middlewares are great features which they're fully customizable. You can define them and reuse on many routers. So once you define the middleware, you can easily assign the router. You can easily assign the middleware to the different routers. So it's a quite nice feature. It's also YAML implemented. You can still use TOML, and I will show you in my demonstration that I use 2 different languages, and both works perfectly. It depends of what you like. There is a beautiful dashboard with a web UI, and in that web UI and in that dashboard you can see how your configuration looks like in interface. So you don't have to just play with configuration files. You can easily see how it looks like. Canary deployments, this is a very nice feature. It's you can achieve that by using services created by Traefik services and load balance between 2 Traefik services. So this is what I will try to present later on. And of course, you have a mirroring. So it's you can copy the network traffic which flies to your infrastructure and just redirect the traffic to some of the services and just see how it behaves. And then you can decide, okay, I'm ready, I'm satisfied with my change, so I can deploy and make the release from my deployment. And console catalog has been also added like another provider. It will be also demonstrated like just an example. So this is the basic architecture of how Traefik looks like. So we have entry points, and we can define many entry points, but just by default we have a HTTP and HTTPS because we are talking about mostly about the HTTP requests. From the right side we have routers, we have services, we have middlewares, and we have certificates for let's encrypt. And we can have multiple providers. It can be a Docker Swarm, it can be a Kubernetes, it can be also file provider when you can define your configuration in the files. And we just also mentioned briefly, but I will talk later about it more, that we have 2 types of the configuration. We have static configurations, which can be defined on the startup time, and dynamic configuration, which can be changed while Traefik is up and running. So there are any restart required. So what is the middlewares? Just middlewares, as I mentioned earlier, you can tweak your request. So once request arrives to your infrastructure, it can be easily tweaked before and after arrive to the destination, to your backend servers. And you can define many middlewares. As I mentioned, they are you can reuse them and assign to the different routers, as exactly it is shown in that diagram. And one of the features is a mirroring, and it can be also called live traffic shadow. So, but to understand mirroring, we need to understand difference between 2 words. What is the deployment and what is release? Because we can deploy new version of the code our infrastructure, and this is called deployment, but there are no any live traffic. So you just deploy it, you have a few containers which contains the latest version of your applications, but you haven't redirected any live traffic yet. So you can see what are the logs and how the application behaves. So and then make the decision. Okay, I'm fine. Now I can, from the deployment, I can make the release, and it definitely helps you to make changes on the infrastructure without impacting your users. So it's a very nice feature. So once you decided it works fine, you can make a release and brings live traffic to your deployments. So that's nice feature implemented to Traefik 2.0 product. Yeah. So this is how it looks like in the diagram. So you have two versions of the application, and you can see that the majority of the traffic goes to the version 2, and some of the percents of the traffic goes to the version, to the version 1. The majority of the traffic goes to the version 1, and of the version 2, you have just some of the parts of your traffic, and you can see how the system behaves, what are the potential problems. You can execute some integration, smoke tests, whatever you like it, and then make the decision, okay, I'm fine, so I'm deciding to release to the latest, to the newest version. Here is the link to the GitHub, when you can see how the feature has been described, and feature request has been described by one of the users, so you can definitely refer to it later on. Canary deployment, so again, similar approach, deployment versus release, but it's instead of switching to the newest version in the one step, we can use the phased approach. So we just redirect the, let's say, 1% of our users to the applications, and it's a live traffic, and we can see how the system behaves. What are the problems? What are the error logs? So you can track everything and see what's the impact of your users. And it just can, if there are any problems, it can impact just a few of your users, because you can decide how many of the traffic can be redirected to the newest version. And if there are no any errors reported, because your application works fine as you expected, you can release it to the rest of the infrastructure. So in the diagram, it kind of looks in that way. So you have a version 1, you can redirect majority of your users to the version 1, and onto the version 2, just let's say 1% of your live traffic, and then you can see how your new containers, new version of the application behaves, what are the potential problems, what are error occurs, and then you can decide what to do if you are happy with your release, if you are going to migrate your entire infrastructure to version 2, because you should end up in that diagram. So everything is deployed to the version 2. So it's all about the canary deployments. What I would like to mention here, just to understand deployment and release. And I will try to show you later on how it works in the live environment. So again, immutable container with Traefik, because in the previous version of Traefik, we were able to use a console like a provider for our certificates. Let's encrypt certificates, because it was a key value data store where you can store your certificates. Currently, it's just available in that solution is available in the Traefik EE. So there are no possibility to add the console like a provider for your certificates. So you need to develop your own solutions if you'd like to scale it up your traffic horizontally with a Let's Encrypt, because currently it's not possible. If you bought your own SSL certificates from the external company, you can build your own image and put the SSL certificate to the container. with Traefik, build the image, store in your Docker registry, and then you can deploy and scale it up horizontally, that particular container. You can also put inside your configuration files, so the same approach, one image which contains your certificates, configuration files, which can be easily scaled up horizontally. So it's kind of solutions which you can consider to implement in your infrastructure. Otherwise, you need to use some own solutions to play with Let's Encrypt. If you have a certificates which can be dynamically updated by Let's Encrypt, because Traefik has an integration with Let's Encrypt, because I haven't mentioned it yet. And for those who are not familiar with that feature, and it's a pretty cool feature because you don't have to maintain your certificates by your own, because everything is out of the box provided by Traefik, by a certification resolver feature, which I will show you in a few minutes with my configuration files. In Traefik, we have also metrics implemented. So observability is a very common feature right now. Everyone would like to know what is happening inside my infrastructure, what is the load, how my system behaves, what are the responses from my services, backend services. And in case of any failure, I would like to be notified that something is happening wrong, so I need to take any action to make my system stable. So if you enable, let's say, if you integrate Prometheus with Traefik, you can get the metrics. You can create nice graphs using Grafana to visualize your metrics. You can use the existing dashboards, or you can just develop your own dashboards if you are not happy with those dashboards which are available in the Grafana market. I will also show you how it works, but just only in the console, because I haven't prepared a demo with Grafana and Prometheus, but I will show you what kind of metrics you can get from the Traefik instance. Another feature is logging and visualizing access logs. So this is how we are also using that feature connected with the Elastic Stack, because by default we have two types of logs. So first logs, Traefik, which generates it's a startup logs, and all things which are related with the Traefik itself, with the binary which you run in your infrastructure. And of course, if you have some mistakes in your configuration files, for example, you did some syntax problems, maybe you can everything track in those logs. You can also see how Let's Encrypt works, how often you can regenerate your certificate. So everything can be taken from those logs, and it can be stored in the JSON format. So it can be easily transferred to the Elasticsearch, because you don't need any data transformation, just a JSON can be stored easily in the Elasticsearch, and you can see your logs in Elasticsearch, in Kibana. So it's a very useful feature. Access logs can be also used to, because logs generated by Traefik, and actually it's true for our entire container environments, should be written to the standard output. And if you correctly set up your environment, you can treat your logs like events and send events to external system, which can be your central logging system. And based on that, you can generate some live data streaming what's happening in your Traefik environment. So we are actually using that feature very often, because as I mentioned, we use Elastic Stack with logs such as Fluentd, and we can take the logs from the containers, process them, transfer them to create some nice dashboards, even with a longitude and latitude points to visualize, let's say, where our users are located, and it works perfectly with Kibana, and of course with Traefik. Some of the configuration tips which you can consider once you play with Traefik. So as I mentioned, there are two types of the configuration. It's a static configuration and dynamic configuration. So We shouldn't mix them. At the beginning, it may be quite confusing, and even for me, sometimes it can be confused which parameters are static, which parameters are dynamic, and how I can manage that. But hopefully, I will show you in the demo the differences between those parameters. So basically speaking, static, you can use a CLI comments like to assign to the binary, and it's those comments, those CLI comments are static, but you can also place them in the configuration files, and it's kind of a static config features. Labels which can be assigned on the container level, they are dynamic, but again, you can also place this parameters into multiple files, and this is actually what I will also show you in my demonstration. You can create a specific directory, you can set the flag and watch the directory, so in case of any change, any updates of that specific config files, you should the Traefik should discover the change and recycle the instance without affecting your users. So it will be done dynamically. Again, more of the advanced rules features can be dynamically changed by middlewares. So it's a feature which comes from the middleware. And my recommendation, and actually Traefik should be run like a container instead of the binary directly from the host. It's easier to maintain your infrastructure where you have everything in the container. But don't forget to implement health checks for your services, because it's doesn't matter what kind of orchestration tools you are using. You can define, I need, let's say, have 5 replicated services of my containers. So orchestrator will replicate your services, but the orchestrator is not aware what's happening inside your container. So on the container level, you should create health checks, making sure that applications which are running inside the containers are healthy. So it's very important to remember that. So demo environment, let me show the diagram and what I'm going to present in my demo environment. So I will use Docker Swarm, and remember that it's, please note that there is an asterisk here, because I don't advise you to use Swarm right now. I know that the company has been bought by Mirantis, and we don't know what would be the future. And, but for me, we use Swarm. Our customers use Swarm, and we consider to migrate to the another orchestrator tools. But for now, we use Swarm, and migration is not just a piece of cake. You need to prepare that. So just wanted to mention that you should be aware that Swarm is alive right now, but we don't know what will be the future. It should be supported for at least 2 years, but it's something which we are not have any influence on it. So use wisely what kind of orchestrator you are going to implement. So again, in my demo, it will be Docker Swarm. We use SSL certificates to issued by Let's Encrypt. 3 domains will be available, which are listed here. I'm also using a DNS round robin from Route 53, because we have a cluster consisting of 4 nodes, but those nodes, each of the public IP addresses of those nodes are assigned to those domains, and DNS from the AWS checks whether my applications are, whether my nodes are healthy. So health checks monitor automatically the status of my cluster. So once, in case if one of my node is down, the DNS will be automatically updated. So traffic will not be, network traffic will not be routed to the unhealthy node. So it's a quite nice feature. Prometheus and Grafana, so it's a kind of tools which you can demonstrate it here. Elasticstack and Fluentd to visualize the data logs. And we'll have a web server and Node.js backend, and a few stacks will be deployed, which are listed here. Diagram, it's pretty simple. So we have a multi-tier application. So Traefik on the top, which is responsible for exposing my services. Web frontend, in my case, it's just the Nginx, but it can be any web server, and Node.js backend. So it's a multi-tier, 3-layer diagram of the demo environment. And I think it's a very common common approach to develop modern web applications. So let's go to my configuration files. So let me switch to my Visual Studio. Just a second. I hope the fonts are readable. Let me know if you would like to have a more larger fonts. So let's go from the top. It's
yes, could we make it larger, please, Jakub?
Sure.
Thanks.
Sure. Okay. So it's a Docker Compose file in version 3.7. It works with Docker Swarm. I implemented the health check because I'm checking whether my traffic, which is running inside the container, is healthy. If it's not healthy, it should be restarted by my by Orchestrator. We expose 2 ports, and we use a dynamic configs. But in my case, all of these files are just the files, and they are not, as you can see, there are not any CLI comments because I moved everything to the configuration files just to show you that you can use also that approach. In my previous presentation, which has been done in summer, I use CLI comments, and you can see on my GitHub that there are also examples how to use CLI comments. But in that examples, I use the configuration files, multiple configuration files. We'll just go through all of these files. One file, it's a static. It's you will see what is inside. So let's go to my files, and this is a static file. So it is log level. It's a YAML. We are using the access log in the JSON format. We added 3 providers actually. So it's a Docker console catalog. It's just an example, and the file, because we are using the few configuration files. Entry points, it's a standard web for HTTP requests, for SSL, and few features, which is the ping command, because I would like to see whether my applications, whether my traffic is healthy, and the metrics for Prometheus. So all of them are available on those ports. And Prometheus, it's just the endpoint metrics. And certificate resolver, so we use Let's Encrypt. The storage is placed in that file. So it's actually one of the persistent data which are kept in my infrastructure. And API, because currently API is available through that command, and it's by default should be protected by basic authentication, just to not expose everything open to the internet. Going back to the traffic, so we have a few labels which are dynamic here. So we enable traffic, and we use new convention names. So we have the routers. The name of the router is T, and it's just only for dashboards, new web UI which has been designed, because we can use some internal features directly from the traffic. We assign to the router certificate resolver called LE, which I defined in my static file, and we would like to use just on the entry point, which is web secure, because we don't want to have HTTP. Here I define the middleware, which is called out traffic. And I assigned that, actually here I define out traffic, and I put the basic, just a username and password. And please remember to use bcrypt to create that password here. We have created here the global redirecting from HTTP to HTTPS. So it's a catch-all rule. And here is the information how to use the ping. So it's health check which I'm using in my configuration. So it's available through HTTPS and through the path thing. And I will show in a second how it works. And some dynamic configuration file. It's strictly related to Docker Swarm. So I use a versioning here because I would like to modify those files. So once I modify the file, I need to upload new version to Docker config. So this is how I'm managing that. So let's go back to the dynamic files. So it's TOML. So again, we can use also two languages to create our configuration. So it's a definition of TLS, definition of routers. And as you can see, I defined a few websites which are not in containers because sometimes we use traffic not only with the containers. So it's example that all of those URLs are fake. So I disabled the certificate resolver because I would be blocked by Let's Encrypt if that URLs will be not correct. I'm assigning the middlewares. As you can see, they are reusable because I defined the HTTPS redirect security headers in the bottom of the file, but I can assign them on multiple routers. So this is the code which can be reusable, and it's a pretty nice feature. And as you can see, there are two actually backends created, which are pointing to the URLs which can be run inside in your infrastructure. It's fake, but it's kind of an example that you don't have to use containers everywhere. Sometimes, for example, if you're migrating from the older infrastructure to the containers, you need to play with that approaches. So it's nice to know that it's possible to configure it in Traefik. And the middlewares which I'm using in my routers, so they are defined in the separate file. And Canary, but I will talk in a second about it. So let's now go back for a second to the presentation and demo time. So let's see how the UI looks like. So as you notice in my configuration file, I defined a few entry points. So web secure, web, ping, and metrics. So this is already available. And we have a few routers created. And I will focus on just on the two of them. So Node app labs cometari.eu and the Canar. So just have a look on it, how it looks like. So we have entry points defined here. We have a name of the services we have created and the type of the provider, that is responsible for serving that specific service. So we defined 3 providers, Docker, file, and console catalog, just for example, because I will not cover that in my presentation. Services. So as you can see, few of them are load balance and one of them is weighted. So this is what would be presented like a Canary deployment, and the middlewares. So all of things I created in my configuration files can be visualized here. So you can see if everything is fine once you deploy Traefik, if it's working correctly. So it's fine, it's Docker. So yeah. So this is an example of the application I created. Just briefly, let's have a look on how it works. So we have a backend, which I presented in the diagram. It's a very simple API, very simple web server created in Node.js, and the frontend, which is a proxy to my Node.js backend. So let me run some network traffic on it. So I use Slapper to generate some network traffic. So Slapper is just a, let's say, HTTP ping, which can generate traffic to see how your application behaves. So we are hitting to that URL. You are sending a request to that URL. And as you can see, I'm receiving the 200 response. That means that everything works correctly. So let's go to the services and let's see how many containers we have available to serve to serve my request. So just only 2 containers are up and running, and it's the basic feature from the Traefik. I think that the most common use case. So we have 2 containers which are responsible for that website. So let me now scale it up by executing Docker swarm command to have more containers. Just a second. Here. So as you can see, we still have 200 responses. Docker service ls. I'm on my local computer using a Docker host environment variable, and I'm connected to that 4-node cluster which I created for that demo purposes. And we have 2 instances up and running. So let me scale it up. Service scale app frontend, and let's run, let's say 10 instances. Let's wait a second. Our config, what we are expecting, that Traefik automatically discover that new containers are up and running and update my configuration. So let me refresh the page, and we should see more containers available here, which seems it's working. It's demo, so maybe it's not, sometimes it cannot work. So, but in that case, it is working correctly. So we have more containers, and let's see what's happening in my network traffic. So everything is working fine. We haven't noticed any problem because we're still receiving 200, and it's actually obvious because we are just scaling up horizontally. We can receive a few 500 errors when we are scaling down, so trying to simulate some errors. So let me now scale it. Remove, let's say, 2 containers. So I will scale it up to 8. So 2 containers are removed from the pool. And the list here should be updated also. Yeah, so we have less containers. We can count it 1, 2, 3, 4, 5, 6, 7, 8. It works too. Let's have a look what's happening in the Slapper. We haven't noticed any problems, so we are lucky guys. No issues. Let me scale it, let's say, to 5, and probably we should notice few 500 errors. But again, I defined the health checks, and yeah, it's works. So we have a lot of luck. Let's use just only 1. Okay, still up and running, so we are good. And so what I presented scalability of the services. So from 2 containers, we run to the 10 containers, then we scale it down. Let me show you now Canary deployment, which is, in my opinion, very nice feature. And for that purposes, I created a separate URL, which is Canary labs cometari.eu. And we have let me show the configuration, how it looks like. So we have 2 services created. First is app1 and the second is app2. And there are very simple containers deployed. The only difference between those containers, app1 and app2, is the version. So once I click refresh, I should have a v1 and a v2. That it means that we are the Traefik takes the incoming request, HTTP request, and route the traffic, network traffic between 2 services. So that's why we have a V1 and a V2. And we use currently Canary is already implemented. So we have a 50% of the traffic goes to the V1 and 50% of the network traffic goes to the V2. How I achieved that? So in the APP1, I created the following configurations. I enabled traffic, I enabled the routers and called the router APP1 and executed which is available through that host. Standard configuration, let's encrypt and web secure. And I created a configuration of Canary deployment through configuration file, because this is the way how we can refer to the configuration stored in the files. And I created the service name, which is called app1_svc, and it's traffic service. It's nothing related to the Docker services, or it's just an internal solution from Traefik. It's app1_vc. In the second application, second service, Docker service, because this is a Docker service, I added just 2 lines. So I enabled traffic, but I created a new service, app2_svc. So we would like to balance the network traffic between those 2 services. How it's achieved is done, the configuration is pretty simple. So we created the HTTP. The service name is called Canary, and we have a weighted balance between those 2 traffic services. The weight is 5 for APP1 and APP2. It means that half of the traffic it goes to the APP1 and second half of the traffic goes to the APP2. So let's go back to the traffic console, traffic dashboard to see how it looks like. Yeah, so the same, the definition which I presented in the configuration files is nicely represented here in a UI. So you can see that we have 2 services created and the weight is 5/5. So half traffic goes to the IPP1, half traffic goes to the APP2. That's why we have once we refresh, we have a V1 and V2. Let me change that behavior. So let me open the Canary file, and let's say that we would like to disable APP1. So I just replaced 5 to 0. Let me save that file, and I need to deploy new configuration because my local everything what I'm just developing here is my local computer. The demo environment is running in the internet, so on the server, on the cluster, consisting of 4 servers, 4 nodes. We need to deploy the configuration to my server. So let me just update that file and change that version. As you can see, I did some tests because it's the 21st version of my configuration file. So I just updated, and let me deploy the traffic to my configuration file, to my stack. So head static traffic. So this is what we should do. Again, we shouldn't receive any, I just deployed new version, so traffic has been restarted. But again, everything is up and running. So we haven't received any 500 errors. So no impact for the user. Since it's already deployed, let me just see if yeah, so traffic has been restarted. It's 80 seconds ago. As you can see, it's healthy because I use health checks. And let's see if the configuration has been updated in my here. Yeah, so here's a 0. So traffic discovered the changes which I deployed. And now we should see just only in my demo V2. Let me refresh. Yeah, so it's V2. So using that options here, you can, let's say, create it in that way and deploy it once again. Just let's do it very quickly because we are running out of time. I've saved it. So, okay, we can deploy it. Yeah, it's for a second we have two instances because I changed the behavior of the start on the order how the containers are starting. So instead of stop first, I have a start first approach. So for a second we had two instances of Traefik up and running. Now it's running. Let me now go back to my browser and for us, yeah, we have a V1 for a while. That means that let's say a few requests generated by users are redirected to the V1. I hope you understood how the Canary deployment works in Traefik. So let's be back to my presentation. And yeah, so I presented Canary deployment. Now I can show you how the metrics are exposed to Traefik in the open metric format. So it will be very simple. Run network Alpine SH. So I will run just a container which is assigned to the proxy main network, and let me add a curl. And because the instance of my Traefik is called main, I can use that DNS name in my demo. So let me make it a little bigger so I can use main. Just a second, what's the port? Entry points, it's so ping is available to that host. So let's just try. So as you can see, I received okay. It means that Traefik is up and running. So it's a health check. So let me now switch to the metrics, and we are receiving the metrics in open metrics format, which works perfectly with Prometheus. And you can see that all of those things can be visualized in the Prometheus, in Grafana. Just add the job in the Prometheus configuration, and you will get all these metrics for your visualization. So you can see what are the HTTP responses, and it's a very nice feature. So I think this is everything what I wanted to present. Summarizing, so I presented how the basic features of Traefik, how the services are exposed, the multiple ways of how configuration files are managed, so static versus dynamic files, dynamic configuration. And Traefik can be easily integrated with a major cluster technology like Swarm Kubernetes. Let's encrypt available out of the box. So it makes generating and reissuing certificates pretty easy. Metric tracing and logs available out of the box. And yeah, Canary deployments and mirroring, quite nice features which you can use in your production environment. So I think that's everything Patricia and all who are available wanted to present today.
Well, this
Thank
is
you.
cool, but you're not off the hook yet. If you stop sharing your screen, we're going to go into Q&A. Do you have it in you to do some Q&A?
Yeah.
Okay, cool.
Let's go. So let me stop my screen. Wow, lots of questions. Wow, I just noticed what's happening in the chat.
Yeah, and I put them actually in a document that I just shared with you, and I have them listed. The first one was a comment from someone at the beginning, and I'm not sure it's a question, but it's from Manuel, so Manuel can say something when I say it, which is APIs, let me type it out, and you can tell us what you think, but let's start with another question. Why are the middlewares running beside? That doesn't look like middle.
Why they're running besides? I think it's how it has been designed. I don't know if there is any specific feature. They are just a kind of an option. So you can create them many middlewares and assign them later on to your routers. So it's like a rules in the previous version, but now it's called middlewares and it's just a naming, right? And I think the configuration is split into two parts: routers, middlewares, and services. So you can have
it's not really literal, it's a naming convention.
Yeah, so you can have many middlewares. You can use them, you don't have to use them, but you can design them, you can configure them and assign to the routers. So it's a tweaking of the request.
Okay, cool. And just a note, Ivor says, thank you. We love Ivor, he's the best.
Thank you, Ivor.
So the next question is, does this system support Graylog too?
Graylog, sure. It's, I mean, you are talking about the logs, right? So we use, in all of our stacks, we use Elasticstack, but you can also transfer your logs to the Graylog, but again, in the bottom of the Graylog, you still have Elasticsearch. So Graylog is a kind of a visualization solution. So instead of Graylog, you can use Kibana. So I think, yes, but it requires some configuration changes on your side.
Okay, cool. And is there a Windows 10 app for monitoring traffic?
Sorry, I'm not familiar with Windows at all. Sorry, I don't know how to answer the question. Maybe we can take it later on and answer.
We can put it in the community forum.
Yeah, yeah.
I mean, that's what it's for. So I'll put that link out there again. Why are you not providing config as config map?
Why you're not providing config? That's again, I use just I wanted to present a few ways of how you can configure traffic. So as I mentioned in my previous presentation, which is on the GitHub, you can use CLI comments which can be added to the binary files, right? In that example, in that presentation, I use files just to distinguish that there are a few options which you can, it's flexible configuration.
Okay, cool. And then Ivor was saying he hasn't been deploying complex things with traffic. Besides code reuse, are there any other benefits to splitting up your traffic configuration into multiple files? And then also he asked, is there anything that the TOML file can do that labels cannot?
So from my experience, it's always better to split the large config files into a few multiple files. So multiple files are easier to manage. And in configuration files, in files in general, you can have a more advanced configuration. So I don't know if we can migrate, let's say, Canary deployments, which I presented, to labels. Maybe it's possible, but for me, it was easier to use just a file. And with Swarm and actually with Kubernetes, it's pretty simple to upload configuration to your server, to your cluster. So answering the questions, files are more for more advanced, more complex configuration.
Okay, cool. I want to say we are just right on time today, and I've loved the audience participation. It's been really wild, if not passionate. And your presentation was amazing. I'm excited for us to share it with everyone. And like I said in the chat box, we will put this to YouTube very shortly and send it out to you. Jakub, thank you so much on behalf of Containers and Traffic, and then the Traffic community for your time and your expertise. Is there anything you want to say to your fans?
Thank you so much for inviting me, Patricia. I hope you get some values from my presentation. There are many ways when you can use Traefik, and we could present it visualizing of the logs, because I was considering maybe you can present Kibana and how we use Kibana with Traefik logs, but I think an hour, it wouldn't be enough for the presentation. So I try to stick as closest to the Traefik as possible, but let me know if you would like to.
I need a Jakub series, Traefik in Poland. We'll talk about it. Okay, thank you, John, for your feedback on great presentation. Everyone have a wonderful night and day. I'm reachable we are both reachable on Twitter and via email. So holler at us if you need us. And thank you again.
Thank you so much. Wishing you a great day.
And
bye bye. Thank you.
Fist bump coming at it. Boom. Bye, everyone.
Bye bye. Thank you.
Thanks.
Bye.